Hello, you're welcome. We'll be starting today some courses on mathematics, especially vector calculus and integral calculus. Mostly the calculus part. So one of the questions you can see in front of your screen, there's a question up there. So there's a cardioid shape, and it's asking you to calculate the magnitude of the line integral of the vector field. So whenever questions of these sort appear, especially in the mathematics part, so you need not to worry. So here, primarily, if you look at this type of a question, when it's asking to calculate the vector field over here, so you have to notice one thing. It's asking about the Green's theorem, okay, and also then you have to calculate the area there. hmm? So line integral calculation has also been asked. So immediately comes to you what comes to your mind? This is a very important concept, and then you have to also identify the region because the shape is cardioid. Okay, so certain concepts you keep. I will give you one master plan to identify the trick. Okay, in the examination. So what you have to remember here, the vector field. Okay, what is the vector field which has been given? So now the vector field is the force. Okay, just like the gravitational field on the earth. Same way, there is a vector. Every magnet has its field. So this field here, it is represented by P I plus QJ. Okay. Now, in the exam, what you have to identify, examination trick is, you need to identify the P and Q values in the Green's theorem. P and Q values in the Green's theorem. I'll explain you the Green's theorem as well. Then you have to go for the line integral calculation. So line integral would be a smart way. Just calculate P of dx plus Q of dy. Once done, then apply the Green's theorem. Okay, Green's Green's theorem. Once this Green's theorem is done, okay, then you have to go for the application of the limits. Okay, which coordinate it is, like whether it's a small sector area or it's a circle or which type of a curve it is. Suppose the curve is of this type, r is equal to a1 plus cos theta. Then for this, the limits, as you can see over here, the notes basically the shape of this sort. Okay, which is in this is called as a cardioid shape, and here the limits will be applied 0 to 2 pi. This can be proven also, but in the gate we have less time, so you just keep in mind, right? If the shape is of this plus or minus theta, then it's a 0 to 2 pi and it's a cardioid. Okay, or if it is in this format also, a 1 plus sine theta, then also it is 0 to 2 pi, then the shape is called as a Lemakan shape. Okay, similar to this on the opposite direction, or r is equal to a 1 minus sine theta. In that scenario also, it will go to 0 to 2 pi. So the limit for this, so a simple thing is r plus minus cos theta, okay, or 1 plus minus sine theta. The limit for this would be, but if your curve is represented as a cos theta, then the limits will be from 0 to pi, and this a circle would be there, right? So radius of this would be equal to a by, and whether it is r cos theta or a sin theta, the same result applies. Okay. Now, if r is your 2a cos theta, then your radius will become a, because radius is this diameter divided by the, so but the limit here would be 0 to pi, and your radius would be a over here. Okay. So now, if it is 2a cos theta or 2a sin theta, the limit remains the same. Okay. Whether it is 2a cos theta or 2a sin theta, the limit remains the same. Okay. Now, if you have another condition here, let's say if your r is equal to a cos to the power n theta, or let's say r is equal to a sin n theta, in these scenarios, so we have added a value of n, then this odd n, for odd cases of n, the limit will be half cycle. Limit for full curve, because of the odd symmetry over there, 0 to pi. And this can come like a rose petal problem, number of petals of rose. Okay, rose petal problem. Then here this would be equal to n, number of petals. If this is even n, then this would be 0 to 2 pi, and it will go to 2n. Okay, now here in this problem, what you have to do, if you go back there in this question, first of all, you have to identify the P and the Q values, which can be easily identified here. P plus C. You just compare this equation, right? The Green's theorem equation with the equation over there. So you can just get P is equal to minus Y and Q is equal to X. Okay, this you have to do. And then what you have to do, then you have to apply the limits, and this can be easily calculated. This is not a big deal. So I gave given you an explanation. Now I'll give you a solution, right? So this was about the explanation, because not the similar kind of a problems will come, same problem will not come, but a repetitive problem. So you should also know the concept. Now, if we have to do this problem, basically, first thing that we are going to do is that we are going to write this line integral like this. Okay, line integral the f dot dr would be equal to p dx plus q dy. Okay, so this p dx and q dy, f is given, that is minus y, and x is given. Okay, so minus y represents your p. If you just look from the curve, this is the basic line integral. From your curve, you can easily see that. Okay, and write this Green's theorem. This equation you have to write. Okay, this is the condition for your Green's theorem. Okay, you write your Green's theorem here. Okay, and now you identify. Okay, which value is your, so you identified the values. So your p value is what? Tell me, boys. P value is your directly minus y, correct? P is your minus y and Q is your x. Yeah, you have to compare your Green's theorem, I told you. So if you do this dou Q by dou x, so that means x by x, dou x by dou x, that is 1. And then you do minus y by y, that is also 1. So this is 1 minus of minus 1, right? See here, if I do dou Q by dou x, right? What is my Q? Q is equal to x now. So it would be dou x by dou x, which will give the result 1. Then what is my dou p? P is my minus y, right? Minus y. Minus of minus y by dou y, correct? So minus minus will become plus 1. So this is 1 minus of minus 1. The result here is 2, correct? The result of this is 2. Hmm? The result of this is 2. Now I wrote this dx, x into y can be also written as dA. dA is the area, dx into dy, x into y, right? Or like for a rectangle, we have an area. So we clearly see my line integral value, f dot dr. Okay, this f dot dr value, what it is converting into? So this f dot dr value is converting into my, okay, when I put these values, okay, inside the bracket, I had this dou q by dou x minus dou p by dou y, and I just saw the value of f is equal to minus y into I plus, right? It was, what was the value of f? F was minus y into I, correct? Plus x into j, correct? When I wrote these values, so minus y was equal to my, if you look at the right hand side of the Green's theorem, right? The Green's theorem right hand side also you have to look, not only the left hand side. Okay, this is also on the right hand side. This is also equal to this close contour p dx plus q dy. So if you notice here, your p value would be equal to minus y, q value would be equal to x, correct? Now you just put this, so dou x by dou x minus dou y by, see this is minus dou y, right? Minus dou y by dou y, your p value, right? P is your minus y. So this value will become 1 minus of minus 1, this value becomes 2. And then this was into dA also. So this is your twice double integration of dA, right? So that means double integration of area, right? X and y. So this would be the complete area, right? So twice into area. So this value will get 2 into area. So here line integration of this value f dot dr is coming 2 into area. Now I told you we have to calculate this area as well, right? If you look at our question, r value is given as a 1 plus cos theta. So it's of the form, okay, 1 plus cos theta form. R is in the form of 1 plus cos theta. So whenever we are getting 1 plus cos theta form, so I have to integrate what are the limits that I have to take for the scenario 0 to 2 pi. That is okay. Then What are the coordinates that I'll be using? I'll be using a sector area formula. Calculate this area in the polar coordinates, right? 2 into area I need. I just need to calculate the area. So what I'll be doing here, I'll just go to the next slide here. I'll just move here. So what I do is I just calculate half into integration of r squared d theta. This is for the area and the polar coordinates. Why is this so? Because I'm just calculating the sector area. Sector area is given as half r squared into del theta. So this is my sector area. Okay. So what I can calculate this as in the polar half integral of r squared d theta. Now I can easily use my trigonometry over there. Okay. And I have the values. I'll put my values half r as 1 plus cos theta का whole square d theta. I just expand this a square plus 2ab 2 cos theta plus b square cos square theta d theta, right? D theta for the entire term, this half, right? So half of theta, limit would be 0 to 2 pi, plus half of 2 will come out, integral 0 to 2 pi cos theta, then plus half of this integral 0 to 2 pi cos square theta d theta. This is how I break down the integration. Here also I'll write d theta, and here it was d theta only. So d theta, I put the limit, it becomes theta. So this is half 0 to 2 pi, right? 2 cancels. Cos theta integration will become cos differentiation is equal to minus sine, right? But integration is sine theta. So this becomes sine theta 0 to 2 pi plus half of, now I have cos square theta term. That cos square theta term, I can use the formula 1 plus cos 2 theta by 2, right? Cos square theta is equal to 1 plus cos 2 theta by 2. This I can use here. Here 1 plus cos 2 theta by 2. So this 4, so 2 into 2, 2 into 2, 1 4 term goes out there. And now I can easily calculate this. Okay. Now if I have to see here, I can easily calculate these values. I can resubstitute back there in the formula. And this is how I'm going to get the solution. Now if I just calculate the first value over there, so I notice here, first value is your just 2 pi, right? That 2 theta d theta will become 2 pi, and this value gives you pi value. This value is your pi, correct? Because 2 theta minus 0 divided by 2. So the first term will come as pi. This term ends up at pi. The second term, sine 2 pi, sine n pi is 0, right? Sine 0 is equal to 0 and sine n pi is equal to 0. So this term would be sine 2 pi minus sine 0. So this term tends to 0, right? Everything is adding. Now I'm just left with the third term there, right? So I have pi plus 0, and I have the third term over there. So that third term calculation I have to do, right? So what is that third term? That is your half of, okay, 1 plus cos 2 theta by 2, right? Plus half of, okay, integral 1 plus cos 2 theta by 2, yeah, 2 d theta. This is the last term over there. Just calculate this term over there. So what is the value of that term that you will be getting if you carefully analyze? Hmm? So if we analyze this term, what is the value of this term that you will be getting? Then you have, see, your area. After that, you have to calculate f. That was 2 into area enclosed, right? Your line integral, this f dot dr is twice into area enclosed. Area enclosed. Here only we have just calculated the area. For this section, we have just done the first part of the area. If you notice this first part of the area, you are just remaining with this part, right? So if you just substitute in this part, you will get the answer. Hmm? So just put this part over there and you will just get the answer. Cos 2 theta by 2, you write down, just break down the similar way. Just keep it half. Then here 0 to 2 pi. This is d theta plus 0 to 2 pi. Okay. Cos 2 theta d theta. Okay. Remember this cos 2 theta will become again integration of cos, differentiation of cos is minus sign, right? If you differentiate sine, it becomes cos. But if you integrate cos, it will become minus sign. Again, this becomes minus sine 2 theta by 2, which hardly matters, right? Because this is again 0 to 2 pi. Again, this is sine n pi value, this term will go 0. If the integration is under sine or cos, this term will go 0. So what are we remaining with? We're just left with this term. This will again 2 pi divided by 2, correct? 2 pi minus 0, right? So this is the value. This value is again coming as pi, correct? Hmm. So what are we left with? Sine 2 pi term also 0. And if you look at the first term, there the first term 1 d theta, that was equal to, yes, that was equal to, the first term was equal to 2 pi, right? Hmm? So pi we have taken, right? Pi. And the third term is equal to your pi. So pi plus pi. So it is basically, yes, the first term was 0 to, yeah, 0 to 2 pi d theta. So that was equal to your 2 pi. Okay, yeah. Yes, you can do like this. Okay, half value is outside. Okay, half value is outside. You have to use the board mass. So the first value came as 2 pi, correct? This value, if you see, if we don't cancel, then it comes 2 pi there, plus 0. Then here the value will come as pi, correct? Right? We have to do the proper board mass. Now, first we have to do inside the bracket, then we have to multiply. We can't do individually, right? First inside the bracket. Was that's why I'm not done the board mass. 3 pi by 2. This value comes to be 3 pi by 2. Now I have to calculate the area. Area is equal to 2 into 3 pi by 2, correct? So 2 cancels. 3 pi can be written as 3.14 into 3. So roughly the answer would be equal to 9.4247. Hope you understood this concept. I'll be coming up with few more questions, okay, in the Green's theorem. So I'll meet you.